Hello, this is Dr. Karaki. The title of this video is Charge of Amino Acids and Isoelectric Point. In order to calculate the charge of an amino acid at a given pH, first of all you have to draw an axis. In the middle of it, you put the pKa of the ionizable group. On the left side, you have the acidic form. On the right side, you have the basic form of this group. So if you are talking about the carboxyl function, on the left side you have the COOH, on the right side you have the COO minus. So the pKa of the terminal COH, for example, is 3. In the middle we put the pKa 3. If the P of the given pH is lower than 3, so the protonated form of the carboxyl function predominates. If the given pH is higher than 3, then the unprotonated form predominates. Same thing applies for the amino group. You draw an axis. On the middle of it, you put the pKa of the ionizable group. On the left side, you have the acidic form of the protonated form NH3+. On the right side, you have the basic form of the unprotonated form NH2. So if the given pH is lower than the pKa of the amino group, which is 8, then the protonated form of the amino group predominates, NH3+ predominates. If the given pH is higher than the pKa of the amino group, so the NH2 predominates. In order to make things clearer, let's solve this exercise together. We'll calculate the charge of lysine at pH 5, 9, and 13. In order to do that, the first step is to know by heart the 3 ionizable groups of lysine, which are the terminal NH2, the terminal COH, and the epsilon NH2 in the side chain R. The pKa's of these groups are given. Now we need to identify the ionization state of these functional groups at each pH in order to know what are the ones holding a positive or a negative charge and the ones that become uncharged at each pH. Now let's start with pH 5. We have to identify the ionization state of the 3 functional groups, the terminal COH, the terminal NH2, and the epsilon NH2 at pH 5. Let's start with the terminal NH2. We draw an axis. On the middle of it, we put the pKa of the terminal NH2, which is 8. On the left side, we have the acidic form or the protonated form NH3+. On the right side, we have the unprotonated form NH2. The pH 5 is lower than the pKa, so the amino group is in the form of NH3+. For the terminal COH, on the axis we select the pKa 3 of the COH. On the left side, we have the protonated form COH. On the right side, we have the unprotonated form COO minus. 5 is higher than 3, so the carboxyl group is COO minus. For the epsilon NH2, we put the pKa on the axis. On the left side, NH3+, on the right side, NH2. 5 is lower than the pKa, so the amino group is NH3+. So the form of the lysine molecule will be the following. We have COO minus, NH3+, and another NH3+. So to calculate the net charge, we have 1 negative charge and 2 positive charge, leading to a net charge of +1. Now we're going to calculate the charge of lysine at pH 9. We're going to start with the terminal NH2. We draw the axis and we select the pKa 8. 9 is higher than 8, so the amino group is NH2. For the terminal COH, we put the pKa 3. 9 is higher than 3, so the carboxyl group is CO minus. For the epsilon NH2, we put the pKa 12.8 on the axis. 9 is lower than 12.5, so the amino group is NH3+. And the form of the lysine molecule will be the following. As you can see, the net charge of this molecule is 1 negative and 1 positive charge, leading to a net charge of 0. This form of the molecule is called Zwitter ion. It's when the molecule is electrically neutral. Now we're going to calculate the charge of lysine at pH 13. For terminal NH2, 13 is higher than 8, so the amino group is NH2. For the terminal COH, 13 is higher than the pKa of the terminal COH, So the carboxyl group is CO minus. For the epsilon NH2 having a pKa of 12.5, 13 is higher than 12.5, so the amino group is NH2, and the form of the molecule will be the following, with a net charge of -1. Only the carboxyl group is charged in the form of carboxylate. The second part of the video is to talk about the isoelectric point. In order to calculate the pI, there is 3 steps you have to follow. First of all, you have to identify the species that carries a net charge of 0. The second step is to identify the pKa values that define the acid and the base rings of this water ion. And the third step is to take the average of these 2 pKa values. Now let's apply this to our example. The first step to calculate the isoelectric point of lysine is to identify the zwitterion species, which is the species that carries a net charge of 0. This is the zwitterion species which was found at pH 9. The second step is to identify the pKa's that define the acid and the base rings of this zwitterion, and they are 8 and 12.5. The third step is to take the average, so 8 plus 12.5 over 2, which gives 10.25. This is the end of this video. I'd like to thank you for your attention. If you find it helpful, please like and subscribe.